Today, we're diving into a really fascinating argument from a Google DeepMind researcher that could flip everything we think we know about AI completely on its head. We're talking about the big one, the idea that it could one day just wake up.
This is the ultimate question, isn't it? For the longest time, it was just stuff for science fiction movies. But now it's a dead serious debate happening in labs and boardrooms all over the world. A lot of very smart people think it's not a matter of if, but when.
The main idea, the one most people are working with, is something called computational functionalism. And it basically says that consciousness is just really, really fancy software. Our minds run on the wetware of our brains, right? So the thinking goes, it should be able to run on the silicon hardware of a computer. You just need to make it powerful enough. But what if that entire assumption is just wrong?
Well, a recent paper claims this popular belief is built on a huge mistake, what it calls an abstraction fallacy. It's a misunderstanding of what computation even is on a physical level. And if it's right, it could mean that billions of dollars and who knows how many hours are being spent chasing a ghost.
Okay, let's really get into this because this is the foundation for the whole argument. The paper argues that computation isn't some natural force of the universe, like gravity or electromagnetism. It doesn't just exist out there. It's something that has to be actively created.
For computation to even happen, the argument goes, you first need what the paper calls a map maker. Now, this isn't some little person living inside the machine. It's an active, experiencing agent, like a person or any organism really, that can observe the physical world and, crucially, interpret it.
And that mapmaker does something absolutely essential called alphabetization. Think about it. The physical world is just a continuous, messy analog flow of voltages and energy levels. The mapmaker is the one who steps in and draws a line, saying, okay, look, anything from 4.5 to 5 volts, we're going to call that a 1. And anything from 0 to 0.5 volts, we'll call that a 0. They impose a neat, discrete alphabet onto a messy reality.
So this is the critical sequence you see here. You start with the continuous physics of the universe. Then, an experiencing mapmaker observes and filters that reality. And only then do you get discrete symbols like ones and zeros. The point is, symbols don't just exist on their own. An agent with experience has to create them first. And right there, in that simple sequence, the entire dream of conscious AI might just fall apart.
This whole idea of a mapmaker leads us right to the absolute core of the argument, the gigantic difference between a map of something and the actual thing itself, the territory.
So on one side, you've got simulation. That's the map. It's a description of a process using all those symbols the mapmaker created. But on the other side, you have instantiation. That's the territory. That's the real physical process happening in the real world.
And this example just nails it. You could have a supercomputer run a perfect atom-for-atom simulation of photosynthesis. The map could be absolutely flawless. But that computer will never, ever produce a single molecule of actual sugar. It won't release any real oxygen. Why? Because it's only manipulating a description. It's not instantiating the real biochemical process.
It's like the difference between a mechanical heart and a biological one. The mechanical version is an amazing map of one single function, pumping. But the real biological heart, well, that instantiates the entire territory. It pumps blood, sure, but it also releases hormones, it helps control your metabolism, it sends all these complex signals. The simulation only ever captures a tiny slice of the real thing.
And this massive difference between the map and the territory reveals what the paper calls a fundamental gap in causality. A gap that, if this argument holds, makes AI consciousness not just difficult, but maybe physically impossible.
Now take a look at this, because it shows the two totally different paths. See the vertical path on the left? That's thinking. Real physics instantiates experience, which lets an agent form concepts. It grows right up out of the physical world. But then look at computation at the bottom. It's a lateral move. It's a step away from reality. It's created when the mapmaker just arbitrarily assigns a physical symbol to a concept. That sideways jump creates a gap you can't jump back over.
So believing that a more and more complex algorithm can just become conscious, the paper calls that an ontological inversion. It's getting the order of creation completely backwards. It's like expecting the map to suddenly create the mapmaker who drew it in the first place. The symbols are derived from experience. The experience is what's foundational.
Okay, but I know what you might be thinking. This is the big counter-argument, right? What if we give the AI a robot body with sensors and motors so it can actually interact with the real world? Surely that fixes things.
To really get why embodiment doesn't solve the problem, we have to look at what the paper calls the melody paradox. Imagine a machine is producing this physical waveform. Its physical path is totally fixed, right? It's just determined by the laws of electronics.
So is this physical process representing the notes of Beethoven's Fifth Symphony?
Could be.
But what if that exact same physical waveform is actually representing a stream of financial data from the stock market?
Here's the punchline. The machine itself has no clue. The physical process is identical. The meaning, the actual content, is supplied entirely by us, the external map makers who decide which alphabet, which key to apply to interpret that raw physics.
So even if we hook this machine up to a robot with cameras for eyes and motors for arms, does that finally bridge the gap? Does that ground the symbols in reality?
The paper argues, nope, not at all. This is the transduction fallacy. Look at the process here. At the input, a sensor turns physical energy into a symbol. Then the processor in the middle just shuffles those symbols around. It's still just operating on the map. Finally, at the output, an actuator turns a symbol back into a physical force. The robot's brain is just a symbol shuffler, completely sealed off from the actual territory of experience.
So, where does all of this leave us? If this argument holds up, what does it really mean for the future of artificial intelligence?
The bottom line is this. Computation is a map, a description of the world. Consciousness, if it's a physical thing, has to be a feature of the territory itself. And no matter how detailed, how complex, or how high-res you make that map, it is never going to magically transform into the territory. This means we're not creating a new form of life, we're creating an incredibly powerful but ultimately non-sentient tool.
And this really reframes the whole quest for AGI, doesn't it? It stops being about creating a new kind of who and becomes about building the most powerful what imaginable. And that leaves us with a final, provocative thought to chew on. If we succeed, if AI builds the ultimate map of our world, what new and maybe unsettling things will we discover about the territory and about the map makers who live in it?